Good morning, everyone. Is it audible? Today we start our sec paper is basic skills in electricals. This block basic skills in electricals deals the different types of electric circuits and the precautionary measures while dealing the electric circuits. Also, it explains the concept of respiration, gives the concept of hand tools of electricals and conductors and insulators, and also explain types of fuses, difference between MCBs and conventional fuses, and also described in the in this block is these four blocks. What are the units? History of electricity, treatment for electric shock, conductors and insulators, types of fuses and MCB and all. Okay, first one we are going about unit one is history of electricity. What is electricity basically? History first unit we are studied about history of electricity. Second unit we are studied about treatment for electric shock, and third unit we are discuss about conductors and insulators. What are conductors? What is basically charge current? What is charge ma? Either positive or negative charge. Any substance gains the electrons, having the electrons is called negative charge. Any substance loses the electrons is called positive charge. Charge is either positive or negative. So electrons having is negative charge, electrons loses is called positive charge. The next treatment for electric shock. If electric shock, then what is the treatment for that? Conductors means allows the electrons freely through them is called conductors, and does not allow through them electrons flow through them is called insulators. Types of fuses and MCB. How to fuse the under MCB we are studying in this particular basic skills in electricals. In this first history of electricity, what topics we have? Basic electricity, effect of electric current and types of electric circuit, precautionary measures, and all these we are studied about in this particular lesson. So in this objectives what we want to understand in this, after going through this unit you will be able to understand about the basic electricity, effect of electric current, know the types of electric circuit. All this will learn from this history of electricity. Electricity is a source of energy which can neither be seen nor touched, but its presence can be experienced in its application like electric bulb, heater, motor, and electric operated radio set, etc. So Greek philosopher Mr. Thales discovered that if amber was rubbed with a wool, means we are rubbing the wool and cloth rubbed with a wool. Amber cloth will be rubbed with wool, or furries would attract the light objects like pieces of paper. Nothing much was done till the year 1600. So William Gilbert and means what happened? Substance gains the electrons is called negative charge. Substance loses the electrons is called positive charge. So this concept we are studying, what is the charge force. So here what it is, ma Gilbert gave the name electricity to the force produced in amber rod by rubbing it with for after the Greek word electron used for amber. The electricity produced by friction is at rest, hence it is called static electricity. Rest position low, it produces the charge and it is said to be static electricity. If electrons are moving is called current electricity. So Greek word electron used for amber. Therefore, the electricity produced by friction is at rest. Friction means opposing force of the body. So opposing force of the flow of electrons is called frictional force. So frictional force at rest produces the electricity. Then it is said to be static electricity. Now, what it is, many scientists carried on the experiments on static electricity, and then Mr. Volta make his voltaic cell to produce current or dynamic electricity by chemical reactions. In the year 1831, Michael Faraday produced dynamic electricity by moving a conductor in a magnetic field. Magnetic field lo electric current conductor carrying means it produces the current. According to Faraday, Michael Faraday observed or produced dynamic electricity by moving conductor in a magnetic field. Electron conductor magnetic field produce చేయటం వల్ల he feels the electricity, produce dynamic electricity in a magnetic field. Therefore varying current conductor produces magnetic field. Varying current conductor produces the magnetic field. Opposite also, converse also applicable. Now, basic electricity. What is this? Flow of electrons in any conductor is called electric current. Flow of electrons in any conductor is called electric current. Its symbol is I. Electric current is denoted by the letter I. It is measuring unit is ampere and measured by ampere meter. So, unit of current is ampere and measured by ammeter or ampere meter. There are two types of current. First one is alternating current, second one is direct current. So alternating current means what is the direct current? Alternating current means alternate. First, there are two types of current. First one is alternating current, second one is direct current. What is alternating current? The current whose magnitude and direction remain alternating at a definite rate is termed as alternating current. The current whose magnitude and direction remain alternating in a definite rate is termed as alternating current. The current obtained by an alternator, oscillator, etc. in AC pulsating and oscillating and interrupted current are its various kinds. Next, direct current. The current whose magnitude and direction remain fixed in a termed as direct current. The current obtained by a battery, generator, etc. as DC current. Next, direct current means the current does not change. It is a fixed direction. Unique direction is called direct current. Alternate direction is called alternating current, means positive, negative, like sine wave. It is moving, then it is said to be alternating current. What are the advantages of AC and advantages or means uses of the AC and DC? Now we are studying. What is AC? AC can be developed up to kilovolts level, kilovolts level. How to measure current ma? Ampere. How to measure voltage also. So AC can be developed up to kilovolts level and after generation at low voltage level. So AC can be transformed from low to high and high to low voltage without considerable power loss. Without any power loss, we can transform the low to high and high to low voltages easily. AC current. AC can be distributed from one station to another at a low cost without any more expenditure. We can transport or distributed AC easily. Now, advantages of DC. DC is essential for the operation of various electric equipments, electronic equipments. DC is essential for the operation of various electronic equipments. DC is better for electric or welding. So, for welding purpose, we are using the DC. Next, what is the pressure? Pressure means electric. General pressure means force acting per unit area is called pressure. Stress and pressure both are having the same units. Here we are discuss about the electric pressure. It is also called as the electromotive force, EMF, or potential difference, PD. It is the pressure that moves the electron to flow any conductor. Its symbol is ERV. Its measuring unit is volt and measured by voltmeter. EMF or potential difference, both are same. Electromotive force or potential difference, both are same. It is a measure in units volt measured by voltmeter. So measuring unit is volt, measuring device is voltmeter. And what is the definition of potential? Amount of work done to bringing the unit positive charge from infinity to certain point in an electric field is called electric potential. So potential difference means in an electric field to change the potential value from one point to another point. What is the difference between potential value in 2 points is called electric potential difference. Resistance means resistance is the property of a substance which gives the opposition to flow of electrons. Electron oppose చేసే వాల్యూనే మనం ఇక్కడ రెసిస్టెన్స్ అంటాం. Through itself, measuring unit is ohm and measured by ohm meter. Potential is measured by volt, and measuring device is voltmeter. Resistance is measured in ohms, and measured device is ohm meter. Is it clear? Potential is volt, device is voltmeter, and resistance unit is ohm, measuring device is ohm meter. Now, work, power, and energy. What is work? The dot product of force and displacement is called work done in mechanics. Here in electricity, power is the rate of doing work. Work done by time is called power in mechanics. Here, rate of doing work. Here also same. What is work? Force into displacement. Here, instead of work, we are using voltage into current. So unit, the MKS electric power is equal to work rate of doing work is called power, where P denotes the power, W work, and T time. So units for electric power is joule by second. Work done by time. No, work done is joule, time is second. Is called watt. It is also called as joule by second is nothing but watt. 1 watt is equal to 1 joule by 1 second. Hence, another name for the joule is the watt second. The biggest unit of kilowatt hour is 1 kW, that equal to 1000 watts. Power in electric circuit. Power in electric circuit, what it is? P is equal to W. P is equal to W. Next. Next, P is equal to W, W is equal to V into I. W is equal to watts, V is equal to voltage, and I is equal to current. Now, what it is? Voltage, V is equal to IR. V is equal to, from that, what it is, more W by I. And current is equal to, from the voltage, what we are getting, I is equal to V by R. Resistance R is equal to, what it is, V by I. Then power is equal to watts, P is equal to W. Then P is equal to I into V. That is the formulas and values for different formulas for voltage, current, resistance, and power. P is equal to VIR, P is equal to I dot V, I cross V. Like that we can take. V is equal to IR is nothing but Ohm's law, no? From that Ohm's law only we are getting the values for our formulas for current. I is equal to V by R, and resistance R is equal to V by I. Now voltage V is equal to W by I also. V is equal to W by I. So your value current charge is bringing from infinity to certain point in an electric field. We are doing some work. That work is stored in the form of potential. So that V is equal to W by I. From that formula, I is equal to what it is, P by V. And P is equal to I. We are in the place of I, you are substituting P by V. V cancel. Then I is equal to P. We are getting in the formula for power. Now variable work we are considering, then V is equal to integral W into R, and I is equal to, in terms of variable values, I is equal to integral P by R. Now, what is the effect of electric current? The flow of electrons through a conductor from this one end to the other end is known as electric current. The flow of electrons through a conductor from its one end to the other end is called electric current. It is invisible, but it is presence can be experienced due to its effect. Physical effect, heating effect, light effect, magnetic effect, chemical effect, race effect, etc. All these are the effects for electric current. So electric current, what are the effects are there? The flow of electrons through a conductor from this one end to other end is known as electric current. Flow of electrons in a conductor from one end to other end is called electric current. It is invisible, but its presence can be experienced due to its effects. What is that? How to feel? Out are the effects? Physical effect, heating effect, light effect, magnetic effect, chemical effect, and race effect that we are studying in this particular topic. Now, next, what are the effect? First one is physical effect. So current flow means how can you feel? That is called physical effect. So whenever any part of our body comes in contact with electric current, while we are standing on ground with the bare feet, then we feel an electric shock. Our body is a good conductor of electricity. Our body is good conductor of electricity, and that is why when current passes through our body, it causes an electric shock. A strong electric shock can cause the death of the person even. So physical effect we feel. So physical effect means electricity, and that is why when current passes through our body, it causes an electric current. In general we feel that, no, so that a strong electric field can cause the death of the persons even. Now an electric shock is caused only when the voltage of the source is equal to or above 90 volts. Therefore, everyone should take care against electric shock. Everyone should want to take the care about electric shock. So, voltage is more than 90 volts, then it to feel the electric effect, that is called physical effect. Next one, heating effect. A current carrying conductor becomes heated up. A current carrying conductor becomes heated up. Conductor ఏదైతే heat అవుతుందో, if the conductor has enough resistance, so opposing force also having more, then it produces a good quantity of heat on account of current flowing through it. Whenever current is passing through the conductor, then the resistance value is more, then a good quantity of heat on account of current flowing through it. Examples are electric iron and heater immersion, heater, etc. All these are we feeling effect of a heat. No, it produces a heat also. Whenever current value is more, it produces heat. Then only we can use electric iron box, heaters, geyser, like etc. So heater, how it is working already we know that. No, that is the example for heating effect of electric current. Next one, light effect. A current carrying conductor becomes light. A current carrying conductor becomes light if the conductor has enough resistance, then it produces a good quantity of light on account of current flowing through it. What it is, a current carrying conductor becomes light if the conductor has enough resistance, then it produces a good quality of light on account of current flowing through it. So that is the light effect. A current carrying conductor becomes light. So light energy, a current carrying conductor becomes light energy if the conductor has enough resistance, then it produces a good quantity of light and an account of current flowing through it, that like nothing but bulb. So if you are switch on that bulb, then we get the light, no, light energy. Next, magnetic effect. A current carrying conductor produces a magnetic field around. Already with it, no, it experiences the magnetic field. Current carrying conductor produces a magnetic field. Therefore, magnetic field around it, then opposite also applicable. Magnetic field, varying magnetic field produces current also applicable, ma. This is observed by Faraday. If a direct current is passed through a solenoid or a coil and a soft iron bar is placed inside the coil, then the bar is magnetized. It can attract iron pieces. Electromagnets, electric bell motors, generators, transformers, etc. work on the principle of magnetic effect of the electric current. So it work on the principle of magnetic effect of electric current. What is the working principle for electric motor and electric bell motors, electromagnets, generators, transformers? All these are the examples for according to magnetic effect. Okay, so that is a working principle of these. Now see in figure what are the parts is there in that motors and shafts: wooden bobbin, gong, next s- stirrer, armature, soft iron core, and push button. All these are there in that particular, um, based on the magnetic effect, soft iron core, all these. Next, chemical effects. Some liquids have a property of producing chemical change. Some liquids have property of producing a chemical change. If an electric current is passed through them, the process of chemical change due to the passage of an electric current is called electrolysis. Electrolysis is the chemical effect. This phenomena is used in electroplating, etc. We are giving some plating designs, etc. We are using chemical effect. Some liquids have a property of produce chemical change. If an electric current is passed through them, the process of chemical change due to the passage of an electric current is called electrolysis. Next, rays effect. What is that? Electric current produces X-rays in vacuum cathode ray tube. X-rays are very useful in the screening of the human body. Many other types of rays are also produced by electric current, such as cathode rays, ultraviolet rays, laser rays, etc. All these are the examples for effect of different, in electricity: chemical effect, magnetic effect, rays effect, heat effect, pressure effect. All these we are completed. So what are the effects of light means these six are is enough. Now, types of electric current. Initially what we are taken, two types of current: direct current, alternating current. Direct current means in a direction. Alternating current means with respect to time the direction of current value changes, current it changes. Now there are four types of electric circuits. That is electric current. Now we are discussing electric current is over, effect of electric current over. Now types of electric current. What current circuits, types of electric current circuits. There are four types of electric circuits. First one, closed circuits. Second one, open circuits. Third one, short circuits. Fourth one, leakage circuits. Basically closed and open, in that short circuit and leakage circuits. So by name itself it is there, no, closed totally. Open means some one side is open. Short means mixing up of components. Leakage means any small gap is there between one component to another component, then we get the leakage circuits. So closed circuit, if a circuit comprises all the four parts: the electricity, medium, controller, and consumer, then it is called a closed circuit. If a circuit comprises all the four parts of electricity, medium, controller, and consumer, then it is called a closed circuit. On putting the switch to on position, the load starts to consume electric power in the circuit. In coming figure, that is figure 1.3 is over already. Now we are going for figure 1.4. If a circuit comprises all the four parts of the electricity, what are they? Medium, controller, and consumer, and circuit. the closed circuit. On putting the switch on, then the load starts to consume the electric power in this circuit. That is the closed circuit. Now we are seeing about the closed circuit. What are the closed circuit and open circuit? Switch on, switch off. Open circuit. In a circuit comprises all the four parts of circuit, but the switch in half position. Switch in off position are the load, then it is called an open circuit. Switch is on position means closed circuit. Switch is off position means open circuit. See in circuits, lamp power supply, switch on, lamp is glowing. Switch off, wire break and lamp is not glowing. See, yeah, observing the first and second figures. Next, third one is short circuit. If the load or consumer of a circuit is short circuited and the current is not passing through the load, then it is called a short circuit. The current is not passing through the load, then it is called a short circuit. In this circuit, a heavy current flows which burns the fuse or otherwise which cause a fire due to overheating of cables and burning of their insulation. All these seen in figure 1.5. Next, first figure we are showing on switch on circuit, switch off circuit. Short circuit means not giving power supply and components are mixed one component to another component with a cause fire due to overheating of cables and burning of their insulation, etc. Now leakage circuit. If due to loss of insulation a phase wire comes in contact with a metallic conduction pipe or humid wall, then a small flow of current is set up from the phase to ground. This type of circuit is called a leakage circuit. This type of circuit is called a leakage circuit. It causes a loss of electric power and reduces the useful flow of current through the load, etc. Now, what are the measures if you are leakage current and short circuit? What are the measures we want to take precautions? A great care should be taken against electric shock while doing any work on the main line. If you are doing any work on the main line, we are using the some precautionary measures. What are that? Switch off the main switch immediately to release the victim of electric shock. If the main switch is not an easy approach, then use dry wood or any other insulating material to release the victim. So if happen the shock, then what we are doing is switch off the main line work, switch off, then release the victim of electric shock. If the main switch is not an easy approach, then use dry wood or any other insulating material to release the victim. Now, a switch should always be inserted in the phase line. What are the precautionary measures we want to take for this means? These points are required. First one is a switch should always be inserted in the phase line. Next, don't touch the main line with bare hands. Mainline does not touch with the hands. Now switch off the main switch before the replacement of a fuse. Switch off the main switch before the replacement of a fuse. Don't disconnect the lead of an electric apparatus from the socket by pulling it out. Always use insulated tools while doing any work on the main line. Before supplying mains to any equipment, check that equipment is in perfect working order and it is properly earthed. Now, all metallic parts and the metallic covers of an electric machine should be well earthed. Before switching or main switch, check the check that nobody is working on the main line. Before starting a repair work or the main line, switch off the main switch and pull the fuses. Now, before starting the job, be ensured that you are the authorized to do the job. Don't touch electrical machines without any purpose. The battery charging room should be well airy and lightened. Don't charge the batteries in a dark or in a closed room. A fire caused due to an electric spark should be extinguished with dry sand, carbon carbon dioxide type of extinguisher. A fire caused due to an electric spark should be extinguished with a dry sand and carbon dioxide type of extinguisher. So we are using that materials in matter, that particular materials. So space is given below for writing your answers. What it is, compare your answer with the given at the end of that limits. What is a closed circuit? So already we learned now that we are wrote here using textbook. Now, so what we are given initial that we are studied in this particular, what are the types of circuit, what are the types of circuit, what is current, what are the effects and what are the precautions we are using, that are major topics in this particular unit. Awareness about electric current and questions what they are asking in exams, effect of electric current, or what is voltage, what how to measure, what is power, what is energy, that we are discussing in this lesson. No? Next, second one is second unit two. That one, first unit. Next, second unit is treatment for electric shock. Treatment for electric shock. What it is? Methods of artificial respiration. Next, new methods of treatment. Before, what are the precautions we are using? What is the shock? What are the types of circuit is completed? Now, treatment for electric shock. What are the treatment required for electric shock? Methods of artificial respiration, new methods of artificial respiration, mouth to mouth mouth to mouth resuscitation. Now, hand tools of electrician and their care, that all we are studying this particular treatment for electric shock. Introduction, what it is, if any person is shocked, in this lesson what we are the major object is my methods of artificial respiration, how to take the artificial respiration in this particular motto. Now describe the concept of hand tools of an electrician and their care. So electrician basic components what are required, that we are studying in this particular unit. Now if the person is shocked by electric current or he is in contact with a live line, then the switch off the main switch immediately. If the main switch is not in easy approach, then we are using pull the victim while keeping yourself insulated by wrapping a dry paper or cloth or your hands. If the victim is close or dry, then you may remove him from electric contact by pulling the edges of his clothes. A dry wooden stick or light wooden plank may be used to remove him from the electric contact. So these are the basic requirements. So we are using initial priorities, these 3 points. Remember that while removing the victim from the electric contact, you must keep yourself well insulated, otherwise you may also get an electric shock. So one person we are removing means we are also getting shock. Now that's what we can take some precautions. This is the next. What are the required methods of artificial respiration? Methods of artificial respiration. If the victim of electric shock is senseless, then lay him down immediately on a dry wooden plank or on a dry bed so that the electricity stored in his body may finish. Never lay him down on the ground because it may be possible that he may not regain sense. Extinguish any fire or flame that may be present in his clothes. Watch that he is breathing or not. If he is not breathing properly, then call the doctor through some other person. Meanwhile, start the first aid on the artificial respiration. There are two main methods of artificial respirations, which are as follows. First one is Sylvester's method, second one is Capper's method. So, before coming to the doctor, we are doing basic two artificial respiration methods. One is the Sylvester's method, second one is Capper's method. What is Sylvester's method? Lay down the victim on his her back on a bed. Lay down the victim on his her back on a bed. Put a pillow beneath his her shoulders so that his her chest rises up slightly. Now sit at your knees near the head and then fold them towards his her chest. Apply some pressure for 2 to 3 seconds and then release the pressure by returning yourself to the original position. Repeat the above procedure 10 to 12 times per minute till normal breathing is restored. This is called Sylvester's method. So this process we are continued. Then this type of method is called Sylvester's method. Next, Schaffer's method. Lay down the victim on his her chest on a bed. Spread victim's arms towards his her head and rest his her arms folded together. Now sit near victim's hips at your knees. Keep your both palms at his her body. Apply some pressure while spreading our fingers your fingers outwards by straightening your arms. After 2 to 3 seconds, release the pressure by turning yourself to the original position. Repeat the above procedure 10 to 12 times per minute till the normal breathing is restored. Repeat the above procedure 10 to 12 times per minute till the normal breathing is restored. This is the Scaffers method. Scaffers method, Sylvester's method. Sylvester method means you are the back side, and Scaffers method means you are the front side, and person is turned into opposite direction. Scaffers method, Sylvester's method. Clear? No. New methods of artificial respiration, mouth to mouth resuscitation. What it is? Resuscitation. Lay down the victim on his her back. Put a pillow. Breathe his her shoulder so that his her head is slightly tilted backwards. Open the victim's mouth. Clean it and place your mouth on his mouth. Blow vigorously into victim's mouth and allow her chest to expand while her nostrils are kept shut. Remove your mouth for a moment to allow the recurring air to escape. Repeat the whole procedure 5 to 10 times per minute. 5 to 10 times per minute we are doing this way, and then check that his her normal breathing is restored or not. If not, uh, um, continue resuscitation. Same procedure you are repeating. Now, note that trainees should practice practically on all the three above stated methods. Use a piece of, this is the mouth to mouth resuscitation, no? A piece of clean cloth or a handkerchief between the two mouths in the mouth to mouth resuscitation method. So, handkerchief is in between the two mouths. Keeping is more important. Now, hand tools of electrician and their care. So, up to this, what it is, what are the treatment for electric shock over? Now, hand tools of electrician and their care. What are the hands tools required for electrician and care? Always use proper and well maintained tools for the job of an electrician. By using improper and defective tools, the efficiency of the craftsman is gently reduced. Use a proper tool for each and every job. The main tools are described as under screwdriver. First one is screwdriver. It is used to tight or loose a wooden or machine screw. It has five parts, namely the improper and defective tools. The efficiency of the craftsman is greatly reduced. Use a proper tool for each and every job. The main tools are described as under screwdriver. It is used to tight or loose a wooden or machine screw. It has five parts, namely the blade, shank, femule, pin, and the handle. The size of the screwdriver depends upon the length of the its shank. See figure for electrician job. 10 centimeters to 30 centimeters size screwdriver are used. Initial equipment what we are using for tools of electrician, screwdriver. It is 10 centimeter to 30 centimeter size. Five types of models are there. See, shank, blade, pin, and handle. Handle, shank, pin, and blade. So this blade of the screwdriver is well tempered so as to have a tough and proper shape. Next, connector screwdriver are used very small screws the size of the connector screwdriver and used for very small screws. The size of the shank is usually 5 to 8 centimeters. Care. Next, the blade of the screwdriver should not be too sharp. So, what are the requirements for this? Always use proper screwdriver as per the head size of the screw. Always use proper screwdriver as per the head size of the screw. Don't use it's like a hammer of a chisel. Next, the handle of the screwdriver should not be splitted condition. The handle of the screwdriver should not be splitted condition. Okay, that is the care for screwdriver. Next, combination pillar. It is used to gripping, cutting, twisting, and jointing the wires. For that purpose, we are using this one. In this parts, what are they? Bent of a handle, rivet, and jaw. Jointing the wires and twisting the wires, cutting the wires, gripping the wires. We are using the combination plier. Its head is plant and it is called a flat nose plier. Also, its middle part is like a scissors which has cutters. The cutters are used for cutting the wires. Its tail side position is called the handle, which is covered with insulation. The size of combination plier varies from 15 to 30 centimeters. Next, care. Don't cut steel wires with it. Steel wires doesn't cut using combination plier. Don't use it like a hammer. Don't use like a hammer. Check its insulation before using it on a live line. Don't use it for holding hot things. Don't use for the holding the hot things. These are the care about combination plier. Next, slide cutting plier. It is used for cutting the wires and for the nipping their insulation. Its one end is flat, which is used for cutting. The size of a side cutting plier is usually 15 centimeter, that's say in the given figure. See. Now up to this what it is, screwdriver completed. Next, combination plier over. Now this one. Next, what it is, what are the uses for and what are the care required for this? Don't cut steel wires with it. Don't cut iron sheets with it. So iron sheets and steel wires doesn't cut using this instrument. Now long nose plier. This is long. It is used for gripping and twisting thin wires and for losing and tightening small nut bolts. Its head is long and round from outside, while flat from inside. A plier with a flat nose is called a flat long nose. Plier with round nose is called a round long nose plier. Its handle is generally insulated. Its size varies from 10 to 15 centimeters. What are the care required for this instrument? Means don't use for tightening and loosening big size nut bolts. Don't apply an extraordinary force on it. Don't apply an extraordinary force on it. Next, poker or broadwell. It is used for making pilot holes in the wood plank, and thus it is very useful in the fitting of switch socket, etc. on wood boards with wooden screws. Its handle is made of wood with a round top. Its shank has a pointed up with flat side, and the rest of the shank is cylindrical like a screwdriver, that is shown in figure. Next, poker or broadwell is required and long nose plier over. Now, hacksaw. It is used for cutting metallic pipes, flats, sheets, etc. It has an adjustable type of or a fixed typed frame. The frame has a variable screw, gliding screw, and a wing nut to hold the blade. The variable screw is fitted to a handle. The adjustable frame can accommodate the blades of different lengths varying from 15 to 30 centimeters. See here figure how it is. Variable screw, blade, gliding screw. Next, wing nut, adjustable frame, and then handle. All these are the parts in this particular instrument. Different lengths varying from 15 to 13 centimeters. The frame is made of mild steel and the blade of high carbon steel. The constructional features of a hacksaw are shown in figure. Hacksaw blade, normally we are called it as. The width of the blade is usually 12 millimeter and the thickness is 0.6 millimeter. The blade is kept straight while sawing, otherwise it will break. Next, care. Keep the blade stretched in the frame. Keep the blade stretched in the frame. Drive the blade in a straight direction on the job. Drive the blade in a straight direction on the job. Carry on dropping the weather on the job while sawing. Protect the frame and the blade against rust. Protect the frame and the blade against rust. These are the care required for this instrument. Next, hammer. It is used in reverting, chipping, etc. The various types of hammers are follows. First one is ball plain hammer. Second one is cross plain hammer. Third one is reverter's hammer, straight plain hammer, and last carpenter's claw hammer. It is used in reverting, chipping. The various types of hammers are these five types. Extra type hammer. Out of the above six of hammers, only ball plain hammer is mostly used for electrical jobs. It is made of cast steel. It has face, post, handle, pane, high hole. Out of these parts, the face and the pane are tempered, but most part is kept soft. The size of a hammer varies accompanied to its weight ranging from 100 grams to 1 kilogram. Three different types of hammers are shown in figure. The high holes of the hammer is made in egg shape so that its handle may not slip further. The forehead of the handle is split into two parts and a wedge is fitted in the slot. In this way, the hammer holds the handle firmly. This is the extra type of hammer. Now, care. What are the types, different types of hammers that were shown in figures? See how it is. Now, care. The handle should be taut and well fitted. The handle should be tough and well fitted. No part of the hammer should be egregious. Drive the hammer by holding it all its ends. Don't work with loss handle hammer. Next, hand drilling machine. Next equipment is hand drilling. Care means what? What is the care required for this hammers? The handle should be tough and well fitted. Handle tough గా ఉండాలి, well fit అయి ఉండాలి. No part of the hammer should be greases. The hammer ని కూడా మనం grease చేయొద్దు. Drive the hammer by holding it all its ends. ఎండ్ దగ్గర పట్టుకొని మూవ్ చేయాలి. డోంట్ వర్క్ విత్ లాస్ హ్యాండిల్ హ్యామర్. హ్యామర్ లేకుండా ఉన్న దాంతో మనము హ్యాండిల్ లేకుండా వర్క్ చేయడానికి లేదు. Now, hand drilling machine. It is used for making holes in the wooden and mild steel jobs. It has a geared wheel handle machine, handle and a drift chuck. A twist drill bit vary from 1 millimeter to 12 millimeter. Figure shows in a hand drill machine. See, hand drill machine. Now, care. Keep it straight. Keep it straight while drilling. Lubricate it gears from time to time with grease. The drill bit should be firmly held by the jaws of the drill chuck. So keep it straight while driving, while drilling. Lubricate it gears from time to time with grease. The drill bit should be firmly held by the jaws of the drill chuck. So this space in so what we are learned this lesson is we completed in this particular paragraph. What care should be? Take while using screwdriver. What care should be take while using screwdriver? That is one. Like that your equipments is taken no in this tools for electrician and uses. What are the precautions that we are questions in this particular topic? Summary. The two main methods of artificial respiration and Sylvester's method and Scaffold's method. Always use proper and well maintained tools for the job of an electrician. How to use hand tools and the care while using these hand tools are also explained in this lesson. Okay. Questions: what are they? Explain the different types of hand tools used in electrician work along their care. Next, explain any two treatment methods for electric shock. Three methods is there, no? Any two methods they're asking for a question. This is the second unit, treatment for electric shock. Next, conductors and insulators. Third unit and fourth unit, total 4 blocks is there. First 2 blocks is one class and second 2 blocks are another class. That two is over. Now we are go with the topic is conductors and insulators. So uses of conductors, properties of insulators, conductors and semiconductors, straight joints and T joint, their pictures and precautions. And what are the summary in this lesson? We have studied in this particular conductors and insulators. What are the main objective in this? Explain uses of conductors, describe the properties of insulators. Uses of conductors and properties of insulators. We are studying in this particular conductors and insulators. Already I told what are conductors, what are insulators. What are semiconductors? What are conductors? Electrons freely flow through them is called conductors. Examples are all metals, even human body also. Next, semiconductors means partially allow through them are called semiconductors. Example, germanium and silicon. And insulators means does not allow through them electrons is called insulators on the flow of electrons. And similarly, we are taking band theory of solids also. We are giving the definitions for these three: conductors, insulators, and semiconductors. Long gap is there between conduction band and valency band is insulators. Small gap is there means semiconductors. Overlap each other conduction band and valence band is called conductors. Okay, these are the basic definitions about on the basis of band theory of solids and flow of electrons through them. Now introduction. Insulator, this is the basic definitions about conductors, insulators and semiconductors. Insulator substances, according to your syllabus, insulator substances through which a flow of current or liberation and diversion in any direction of free electrons not easy are called insulators. Means does not allow through them easily is called insulators. Some insulators have 4 and some other have 8 electrons in their outermost shell. Substance having 8 electrons in their outermost shell are very good insulators. In chemistry, such elements are called inert elements and they do not combine with any other element. In semiconductor, the energy gap is very small and very little. Energy is needed to transfer electrons from the valency bond into the conduction bond. Substances through which a flow of current, that is flow of free electrons, can be set up easily are called conductors. The number of free electrons present in the substance decides its conductivity. Most of the metals are good conductors. Most of the metals are good conductors. Next, properties of conductors. They have specific resistance. They are mathematically rigid. If the conductor is a metal, then it should be ductile. Okay.